In this video, we're going to talk about how to find critical z-scores, which are a necessary component for our margin of error. So when we talk about the critical z-scores, we use the notation z star right here. This represents what's called a critical z-score. And what's nice about these is that they correspond to various levels of confidence. So these will usually be given to you in the problem as 90% or 95% or 99%. And what's nice is once we have these critical z-scores over here, we'll have them forever, and they're not really going to change for the rest of this chapter at least. Eventually, we'll talk about something called critical t-scores and how we calculate those. That's a little bit different, but we'll be set for this chapter. So what I want to think about in order to find these critical z-scores is they're going to correspond to our levels of confidence. Now, confidence intervals depend on what's called the central limit theorem. We talked about that in the last section. The central limit theorem said, hey, as long as you meet certain conditions, the distribution of your p-hats is roughly normal. And when we say we want a 90% confidence level, we want roughly 90% of my data, or 0.9 to be the proportion, in the middle. I want to talk about this middle 90%. What I want then for the critical z-score is there's going to be a z-score right here and a z-score right here. And what's nice is because this is the normal distribution, that means that the mean of this distribution is 0, which means that these two should be the same, but they'll have opposite signs. So I really only need to find one of these, and I'll get the other one for free. And it turns out I only need one anyway, but it's nice that they're going to be the same. So what's nice is I can use what I know about the normal distribution. That's why we talk about it early on. It is so important for this class. I know that I want 0.9 to be the area in the middle of my normal distribution, which means that the area in the left tail and the right tail together, these two areas should add up to be 0.1. And because I know that the normal distribution is symmetric, I know that the area in just one of these tails would be 0.1 divided by 2, or 0.05. So I'm going to go searching for 0.05 in my z table. And remember, I'll have to remember that this is actually an area, which means I'm going to be looking at that big mess of numbers in the middle of my z table, and I'm going to try and work my way backwards to find a z-score. So 0.05, let's hop over to our z table. We want an area of 0.05. Let me erase this so that we can start fresh. So we want 0.05 is what I'm looking for. And again, this represents an area, which means I'm looking in this big mess of numbers here in the middle, and I'm going to work backwards to find my z-score. So 0.05. I'm already kind of looking at this row right here, that's too many decimals. I want 0.05. Here's 0.0505, and here's 0.0495. So I'm actually kind of looking, it should be roughly halfway between these two. It is technically closer to 1, and I'll just give that to you. But I know that my z-score is going to be somewhere between negative 1.64 and negative 1.65. Some textbooks will split the difference, and they'll say negative 1.645. I'm going to say negative 1.64 because it's closer. So we want negative 1.64. So the z-score corresponding, the z-score corresponding to this particular distribution is z equals negative 1.64. Now, for critical z-scores, I don't actually really care about the sign, which means that I'm going to use the positive version just because eventually when we talk about margin of error and building a confidence interval, I'm going to need the positive case and the negative case anyway. So I'm going to leave this as positive 1.64. So the z-score corresponding to 90% is 1.64. One thing I want to show really quickly too is that this z-score over here, this should be positive 1.64, just to show that. If I wanted to find the area to the left of this z-score right here, that would be 0.9 plus 0.05. So let me hop back over to my z-tables. Should be 0.95. So I would be looking for 0.95. Whoops, let me erase. 0.95 in my table. And I see right here 0.95. Where is that? Here's 0.9495 and 9505, which would correspond to 1.64 or 1.65. So we have the positive case right there. Let's hop back. The next case that we want to talk about is if we're working with a 95% confidence interval. So I can use roughly the same picture. Some of these values are going to change though, because this time around I want the area in the middle to be 95% or 0.9. So here's 95% of my data that lives in the middle, or 0.95 as an area. Once again, I can find the area in the left and the right tails together if I take 1 minus 0.95 to end up with 0.05. And then if I want to talk about the area in one tail specifically, let's just use the left one because it's easier. That would be 0.05 divided by 2 to get 0.025. So I'm going to be looking for 0.025 within the area of my table. And again, I'm trying to work my way backwards to find a z-score. So 0.025, hopping over to my tables. We're going to scroll up and look at this one here. We want 0.025. So here's 0.026, that's pretty close, not quite it, 0.0256. And actually we hit the nail right on the head right here with 0.0250. So if I work backwards to find my z-score, that's going to be negative 1.96. So negative 1.96, or rather in this case, we'll just take the positive case as positive 1.96 for my critical z-score. So the critical z-score for a 95% confidence interval will be positive 1.96. And we can repeat this process one more time to work with our 99% confidence interval. Let's just go ahead and do that real quick before we wrap this video up. So this time around, I want the area in the middle to be 99% or 0.99. So that means once again that the area in the right tail and the area in the left tail together would be 1 minus 0.99 to get 0.01. So that's the area in the two tails combined. If I wanted to talk about the area in just one of those tails, I'm going to take 0.01 divided by 2. I end up with 0.005. So this is the area that I'm going to be looking for within my z-table, is 0.005. So if I hop back once more, 0.005, let's erase this so that we're not distracted, 0.005. What I'm going to see, I'm kind of jumping ahead here, is it's going to be halfway between these two right here, which means that my z-score will either be negative 2.57 or negative 2.58. It turns out that 2.58 is a little bit closer if we were to zoom in a little bit more using some other methods, but we'll just say 2.58 is our critical z-score. So the critical z-score for a 99% confidence interval is 2.58. And what's nice is this table can be used for all confidence intervals regarding proportions. And you'll have access to this on your formula sheets for quizzes and exams. So this is nice because we can use this method for other confidence levels, the vast majority of confidence intervals are done at the 90%, 95%, or 99%. But if there was a weird scenario where I wanted a 98% confidence level, well, that would change my critical z-score, and I could use a very similar thought process to find that critical z-star corresponding to whatever confidence level that I wanted to. But these three cases